Hi everyone, my name is Raquel with adtmag.com, and I'd like to thank you all for joining us. The topic of today's webcast is 3 Pillars, 0 Answers, Rethinking Observability, sponsored by Lightstep. Before we begin, I'd like to cover a few housekeeping details. There will be a Q&A session towards the end of today's presentation, so please type any questions that you may have in the Q&A box. Lightstep has provided some great resources, so please take a moment to check those out. And additionally, this webcast is being recorded, so keep an eye out for a link in your email to rewatch the presentation or share it with a colleague. And now I'd like to pass the time over to our speaker today, James Burns, who is a developer advocate and head of research at Lightstep, to get us started. The time's now yours, James.
Thank you. So welcome to three Pillars with 0 Answers. I'm James Burns, and my background comes from working on systems at scale at Twilio and Stitch Fix. I was part of the platform team and build out pillar-based solutions for these different sorts of approaches that we're going to talk about, as well as taught people how to use these different sorts of approaches to solve real issues with their systems. So that's where I'm coming from. So let's get started. And there are going to be 2 parts of this. The first will be a critique of the approach that most people take to 3 pillars, and then suggestions for new scorecard at the end. So I think we can all agree that observing microservices is hard, and it becomes harder as there are more and more of them. And so there's this sense that this is a solved problem. And I've actually said this to people before, which makes it funny to present as well. But if you say, hey, who's already solved the problem of operating lots of services at scale? People look at people like Google and Facebook and say, well, they've solved this for more than a decade. Maybe we should do what they do. And they use metrics, logging, and distributed tracing. So we should do that too. And an important thing to keep in mind with that is that they're doing at scale. The number out of Google, I think 3 or 4 years ago now, was that they do 5 billion RPCs per second, or remote procedure calls per second. And so when these companies that have solved this problem solve it, they solve it for that kind of scale. And we'll go into some detail about how that tension ends up influencing the different choices. So the conventional wisdom is fundamentally wrong. It's dogmatic. It's often represented as 3 pillars. People talk about it. People create check boxes. They just say, get something in place for metrics, logging, and tracing, and we're done. We've done observability. But let's look at what each one of those pillars are when people talk about it. And this is what metrics look like. They're often squiggly lines. Sometimes they're stacked charts. Sometimes they're even heat maps. But they're counts of things that have happened, or they're what a particular thing was at a particular time. And so because there are many of them, you end up having to do statistical operations on them. You have to sample them, and then you have to draw lines between the samples. The next pillar is login. And most people have a more intuitive understanding of this. It's the process the developer goes through to create some kind of output, either structured or unstructured, that will help them understand the internal state of their program on purpose. So it's usually meant to be consumed by human, sometimes that same developer. And it's sort of unevenly applied generally. There's a focus on the things that the developer thinks will happen, the way they think that the system will fail, and not on other things. They're often used to generate some statistics as well. And lastly, there's tracing. So tracing usually looks something like this in people's minds, and this is a screenshot of Zipkin. And what a trace is the amount of time it took to do different parts of work for a particular transaction or request, and how those pieces of work related to each other. So which pieces came before other pieces, which pieces were in response to other pieces of work. And we call those pieces of work spans. We call the whole thing a trace. And it's funny, but worth noting that there is this, we end up with this grouping because humans like threes. They like 3-letter acronyms. They like Snap, Crackle, Pop. They like 3 flavors of ice cream, and they like 3 Stooges. So there's this gravity towards, like, let's have 3 things and let's check them off and let's say we're done. And the reality is that each one of these different approaches has fatal flaws, and we're going to talk about all of them, including the flaws that distributed tracing has, which is one of the main tools that Lightstep works with, because it's important to understand what you're trading off and how that trade-off works. So first, to talk about metrics, the most important trade-off in metrics is that it's not just enough to collect data about what a certain thing was at a certain time. You want to use metrics to understand variation. And that variation ends up being expressed as dimensions or tags. And as the number of tags grow, and as the variety of values within a particular tag grows, you have an explosion of what we call cardinality, which is the different ways that a particular measurement can be combined with other measurements to create lines, basically. So this is a line from an internal system at Lightstep, and you can see that something changed that made things get slower, or had more requests. We don't have a label on this line, and then you can see in the lower part that same thing, but broken out by a particular tag, lets you see that one part of the system varied a lot, whereas the other 2 parts either varied in the opposite direction or didn't vary at all. So without this information about the root of how things varied, it's very hard to reason about what a metric means. And I spoke at the Observability Practitioners Summit at KubeCon this last year, and dug into this a little bit deeper if you're looking for more information about that as well. So the reality check for login. Often it's not a single log per request that happens. So there's lots of different things inside the handling of a particular request that a developer thinks that they might need to know in order to understand the behavior of their application. And so and it's not just one application, because as you move to microservices, there are multiple services being called for a single request. And so you have this explosion of log data. And so as your rate goes up, as you add more microservices, the just pure volume of logs go up. And then the process for collecting those logs and the cost of storing them for however long you think you're going to need them to be able to reference them ends up costing truly amazing amounts of money in a not good sense of amazing. And having managed these sorts of services before, it is the best case that 1% of the data ever gets accessed. It's usually significantly less than that, because most of it isn't what people need to know on a day-to-day basis. It's just in case. And there's always that famous log line, which is, this should never happen. So if your logs are full of that, you've got other problems as well. And lastly, talking about the fatal flaws of distributed tracing. So our CEO, BHS, worked on this solution at Google before, and so their solution prior to this was logging. And since logging aggregation definitely can't work at Google scale without sampling, they would aggressively sample or choose some subset of the logs to store and to collect and to store. And because that sampling wasn't aware of the relationship of the different parts of a transaction, of a request, then the ability to put together information about what happened to a particular request was a big gap. And so he looked at this problem and designed a solution for distributed tracing called Dapper. And so Dapper also sampled, but it would sample based on every transaction or every request. And so you would, if your request was sampled, you would get the full story and not just pieces of stories from lots of different places. But again, volume is excessive, and in some cases, the volume that comes out of distributed tracing can be more than login. And so they ended up choosing to only retain 1 out of 1,000 traces. And then as that got aggregated, they found that they couldn't even afford to store the 1 out of 1,000 traces. So they ended up only storing 1 out of 10,000 traces. And so usually when you're looking at what's wrong, and it's something that requires you to dig deeply into the system, it's something of an outlier. It's not happening all the time. And so for high volume systems with this level of sampling, maybe there's a better chance that you get to see the thing that's interesting to you. But for lower volume products, this sort of aggressive sampling means that they often couldn't see the data that they need to see. So the bottom line out of all this, to review, is that there are fatal flaws for each one of these. Either your cost goes up, or you sample, or you have issues with cost and cardinality that restrict the way that you can use a particular solution. And to summarize all that, there is no silver bullet. There is no one solution or even a combination of solutions just cobbled together that will solve the issue. Another source of confusion, often with this, is that there's the data versus the user interface on top of that data. So this is a search for computers. You can see that also returns monitors. Similarly, the UIs for a lot of these different sources of data, of telemetry, are significantly different. So you have metrics drawing lines, you have logs sometimes drawing lines and sometimes showing a list of entries. You have traces also generating metrics and showing lines of information and showing dependency graphs. And you have all these different things that aren't often tied together in a sensible way, and still are not fundamentally oriented towards the user's needs, the people who need to consume this data to solve problems. And we'll talk about those specific problems as we go through the scorecard. So metrics, logs, and traces, they are just data. They're not a feature. They're not a use case. They're things that can help you understand your systems, but each one of them does not actually solve a problem itself. So let's talk about a new scorecard that we can build for observability based on this information. It's important to start with a shared mental model. So there's two main things we're going to talk about here. Goals are related to how our services perform in the eyes of their customers, and everything we look at should take a service-centric view. So it's not necessarily the immediate the end consumer. So it's not necessarily the person who loads the web page. If your microservices deep down in the stack, it's what what the people who are immediately using your service are doing. That like it matters what the high level impact is to that consumer, but you need to see it presented within your scope of action, within the things that you can change, and that means a service-centric view. And then there are the activities that the people who own that service, the team of developers or operators or DevOps, do to accomplish goals. And so another quick vocab refresher. So SLIs, or service level indicators, are an indicator of health that the services consumer would care about. And that could be anything from another API to a mobile app to something else. But the important point here is that, for instance, if you have a queue system like Kafka, the SLI is going to be how long it takes a message to get into or out of that queue for a particular topic. You wouldn't care, and the consumer doesn't care about the CPU to load on the cluster or the number of nodes they're running, because they care about how long it takes to get their data in and out of the system. And this is the same case across pretty much any different kind of service that you would use. Is the thing that people care about is some kind of end-to-end experience, and not the things that can affect that experience. That's not their concern. So there are two fundamental goals that we use observability for, and the first one is gradual improvement. So if your customers are saying, hey, this particular web page is too slow, or like taking this particular action in the API takes too long, there's going to be a process that happens over weeks or months or quarters that you try and move that SLI so that it more closely conforms with what your consumers want. The other case is rapid restoration. So if an SLI, even if it wasn't quite at the optimal level, was at a level that the customer or the consumer had come to expect, and suddenly it's not there, either because it's taking much longer or because every response is errors, or even that the data isn't correct, there's the need to restore that SLI to the level that the customers are expecting. And so this is something that needs to happen right now. It's the kind of thing that wakes someone up in the middle of the night. So there are two fundamental activities that support those goals. And these are detection and refinement. So detection is about measurement, and precise measurement. We'll go into some detail about that. And refinement is about the process of figuring out what might be causing the SLI to be of value that you do not want. And so it's a search. And it's important to, this ends up being sort of a collection of things that go wrong, but it's important to talk about how statistics and how sampling can impact this. So this is an example of 4 different graphs based on P99 measurements, and the difference between those is how many samples or how many values are rolled up into a single sample here. So in the first case, we have a value recorded for every second. In the second case, we're collecting things into 5-second values, and in the third and fourth case, 10-second and 25-second values. And you can see how the existence of what are bad experiences for customers eventually just become, well, it looks like it's a little bit higher. So the frequency that these things are able to be collected at and represented at end up mattering a lot. So let's talk about a scorecard for detection in light of all this. And so there are different things that you need to have to be able to do detection effectively. You need to be able to have cardinality. You need to be able to distinguish between, even at the most basic levels, different requests to different resources. The performance of a particular resource, and this is a mistake that I see fairly commonly, it's going to be different between HTTP requests that makes a change and HTTP requests that reads data, because those have different implications on how they're implemented. Even if that system goes directly to a database, the performance of reads and writes are going to be different. And so if you're not able to have the cardinality that makes that visible, then you're going to have a hard time understanding how your system performs, but also understanding if that performance has changed. You aren't even going to be able to express an SLI for those different things differently. And there's this desire to say that, well, cardinality is expensive and we shouldn't pay for it. But without cardinality, you can't distinguish things that matter. The other important aspect of this is the ability to understand both sides outside of the application, basically. So to understand the consumer, in consumer experience, you're going to want to be able to collect information and associate that information with your internal measurements from mobile applications, from web platforms. On the other side of things, as your application uses cloud services, or what we call here black box OSS, OSS that doesn't have any internal instrumentation, you're going to want to understand how the things that you depend on that aren't your application and aren't even written by your company or other development teams, how they're behaving, and how they're behaving in terms of variance as well. The second important point here is fidelity. So fidelity is about correctness, and there are exclamation points here because this is actually something that gets done wrong so frequently. And so what happens is in some cases you'll have a distribution of latencies that you want to establish what the 99th percentile is. So you want to understand the performance of outliers. If that isn't done on a global basis, if you have percentiles generated within each particular application and then you just merge them together by averaging, basically you destroy any data that might tell you what the actual 99th percentile is. So to statistically correct 99th percentiles are necessary to understand what the outliers actually are. There's no statistical value in merging P99 values by averaging them. Data is just gone, and you can try and make decisions based on those, but they're going to be pretty deeply disconnected from the actual facts of what's going on in your system. You also want, to the original point about frequency, you want to be able to access samples that are high resolution, at least at the second level, so that you can see things that are brief impacts or happen on a regular basis but are far enough apart from each other that otherwise they would get averaged away. And then also, of course, you want all this data in a relatively recent form, because it doesn't help to detect an issue 10 or 15 minutes after the issue started. You've already had the business impact. It's probably getting worse over the amount of time. So you want to be able to do analysis of this different accurate information as quickly as possible. And we like to target as an ideal for a model 5 seconds of lag between what's happening in the systems and what's being displayed. That should be the goal. So let's talk about this refinement action and why it's necessary. As we deploy more services, And as we have more teams managing different services, the ways that these services can interact and create new failure modes expands. And we all have seen this curve now. The thing is that the number of things that are actually things that your customer cares about doesn't change. So you have a responsibility to manage a particular line to meet customer or consumer expectations, and you have a whole bunch of things that you don't control, that you don't understand, that are creating additional failure modes below you, and then that just keeps growing as the business grows. And so what you need is a tool and a process to help you understand what might be broken as quickly as possible. And that can't be just to present you with all the information from every service, because that's not going to be something that can be processed by human, and especially in the amount of time that you want when you're trying to address one of those quick issues. And so it leads to this refinement process, and when you discover variance, you try and explain the variance, and if it doesn't explain the problem that you're seeing, then you need to discover different variance and do that until you find a variance that explains the difference in performance you're seeing, and that you can actually deploy a fix for that. And as yet another side note, there's because this information isn't presented this way, to go back to the UI problem, a lot of the time P99 is presented as a line, and you go, okay, well, P99's higher or lower than we want, when in fact the performance is actually a shape. And so this is a histogram, and on this histogram, this is showing a full distribution. The P99 line is not in the highlighted part there. It's the line in blue with the little note on the top. And I think a lot of the P99 idea has come from this idea that distributions are normal, and so like they follow a bell curve. And so P99 has a specific distance from the center of experience. And in reality, almost every distribution I've ever looked at in any operating system is not normal. A lot of them look like this, where you have a lot of really fast requests, and then you have one or more slower areas. And part of what needs to drive the refinement process is the ability to highlight a particular subset of that distribution of information about performance, and understand why that's happening, understand why some subset of things are taking, in this case, I guess, almost a second. So sorry, I should have started with an explanation of what this represents. So on the left side is the number of requests or operations that took a particular amount of time, and that's logarithmic. So each one is 10 times more. And along the bottom is how long they took. So this is indication of how frequent a particular amount of time was spent on a particular piece of work, if that makes sense. You can ask me in the Q&A if it doesn't. And so what this does is sometimes there are groups of things that take a certain amount of time that are different from how other things take time. And so you want to be able to look at those separately and understand what's causing them to take more time or even less time in some cases. So here's our scorecard for refinement. And again, cardinality matters. And it's my opinion as well that it matters more than in detection, because this is when you really use cardinality to try and split things apart, to try and make hypotheses and validate them or reject them. And so it's really important to have the variance present that allows you to even do that, or to start creating explanations of what's going on. Correct data continues to be very important. If you don't have shapes, if you only have lines, if you have to choose which lines you need up front, which may or may not be the lines you end up needing, that makes it really hard to do refinement as well. And you also need to be able to retain the data, or at least the shape of the data, long enough to look at what normal is. So anytime you come into a new problem, the question ends up being like, yes, this thing that the service is doing doesn't look good, but does it always not look good? Is it normal or abnormal for it to have this particular behavior every hour or every day or every week or every month? Maybe this is just the process that runs every month, and that's not at all related to our problem. So you need enough information to make that kind of assessment. You continue to need correct statistics. If you're doing refinement and if you're taking actions based on that refinement, it's not going to be possible to take actions that have the outcomes that you want if you can't see what the state was before and after that action. So if you want to do a rollback, if you want to increase capacity, if you want to do all these different sorts of things that you usually do to try and improve performance, if you're doing that based on information that's fundamentally incorrect, it's not going to turn out well. I mean, you can get lucky, but that's not generally a good plan. And there's also this need to reduce scope, so that if you have a whole bunch of different services and something at the bottom of that chain of services throws an error and that error propagates all the way up, you don't want to spend your time trying to explain that each one of these services in between is actually fine. You want to be able to quickly suppress all the intermediate messengers of the error and just look at where the error came from and what might be related to that. So wrapping up. First, a hint at how we think about these trade-offs. So, design your own observability system. Here's 4 things. Choose 3. You can either have high throughput, high cardinality, a lengthy retention window, or unsampled data. And this is something that we've spent a lot of time thinking about, because we believe that this ends up, well, it's not a false dilemma, but like you want enough of each for a particular case. And that's where when you're not focusing on the pillars, when you're instead focusing on trying to accomplish observability, you can actually do that. So recognize this representation of sampling for Dapper. What if you're not operating at Google scale? What if that's not something that's happening right now or likely to happen in the near future? Well, there's something different that you can do with tracing in particular. So we like tracing. I like tracing. It gives you this context. It gives you the ability to attribute causality, to say, hey, this thing was caused by this thing, and like if this chain of services has an error, it came from the service that was at the bottom of that chain. The downside, like we talked about, is just the pure volume data. But what would happen if you were able to collect 100% of that data for some period of time that allowed you to make better sampling choices? So sampling that was informed by other things that were happening in the system, sampling that was informed by active investigation of hypotheses, and unsurprisingly, that's what we'll talk to you about. But here's the observability scorecard, and we hope that this is useful for everyone, for both detection and refinement. The ability to have appropriately costed cardinality, correct statistics, and enough information about context on both the front end and the back end of any particular service, as well as recent data are very important. So Lightstep, how do we come into this? So what we've done, and the design trade-off that was made is that, surprisingly, the collect 100% of the data for amount of time that you can make specific cost trade-offs around, and then build services on top of that data platform that help directly serve the needs of developers who need to answer questions. And so some of the things that we do, automatic deployment and regression detection. So in the case of deployment, if we see a deployment happen because the tags associated with a version have changed, then we can more aggressively collect data on either side of that with more cardinality, so that you can more easily see whether that deployment created a problem or not. If there's some other kind of regression in terms of increased latency or increased error rate, we can also detect that, and again, collect more data on either side of that time frame to help someone understand what might have changed. And we do that using things like correlations, so that we can say, hey, this particular piece of the latency for this particular operation, this particular activity has gone up, and it's gone up for this particular customer ID. And to be able to, among even millions of customers, to be able to provide that kind of comparison between what's changed and why it may have changed, or hypothesis as a service, not the official name, that we're able to provide. Also, this data is as close to real time as we can make it, so that you're looking at the data now, not the data as it was minutes ago even. Building custom alerting on this, and one of the main things, and since the beginning of the company, the goal has been that we should earn your data, that we should be able to turn your data into the most useful form to understand and operate on. So the point isn't to lock you into a particular way of generating data or a particular form of collecting that data. All those things are becoming standardized, and that standardization started with the founders of the company working with other companies who are in the same space, and that's progressed quite well with the Open Telemetry initiative. You should be able to send your data to whichever observability vendors you're interested in, and you should be able to compare their ability to surface useful information, useful observability insights out of that. And there really are no cardinality limitations because of the way we approach the problem. So that's all I have. I invite you to go to lightstep.com/play, and that's a sandbox that we have that allows you to step through different scenarios and understand how this actually works in different simulated environments in terms of troubleshooting all kinds of different sorts of things. And if you visited that before, I invite you to visit again, because there have been new scenarios added over time, and see if that helps you understand both in the sense of how the scorecard is met and how you could approach these sorts of challenges differently. So thank you, and I guess we're ready for some Q&A.
All right, awesome. Thank you so much, James. So yeah, if you have any questions, please set them in the Q&A box now. Let's see, our first question is asking, most of our applications are built on a monolith, and we've considered transitioning to a distributed service-based architecture. What would be the best way to start to that transition?
Well, an essential part of that transition is understanding the behavior of your application now. If you don't understand the dependencies that exist within the monolith, it's going to be significantly harder to understand them when they're in separate applications. And so building out the observability and integrating telemetry into your monolith is a great place to start. And then the process of moving things out of the monolith is of course a huge topic itself. But I personally favor an API-based approach. So you figure out what kinds of questions you want to be able to ask about a certain set of data, or what operations you want to be able to take on a certain set of data, and then move that out. And with then the same telemetry, but extended into another application. And you'll probably see that networks are significantly less reliable than you may have been led to believe. But that this is important for you to understand exactly what you're doing and what you're trading off, and how your performance starts varying when you start moving your application logic into different places and your data into different places.
Okay, great. Another question here is asking, is it best to leverage different tools for metrics, logging, and tracing, or should there be one tool for all three?
I think you need to figure out. You need a tool that's observability centric, which means that it integrates information from all those different places. There's this desire for a single pane of glass that presents all these different sources of data in the format that people are most familiar with, but in actuality that ends up increasing response time, even if those are all in the same actual platform, because the presentations don't really match with each other, and you need something that's more focused on surfacing answers and surfacing insights out than a particular presentation of that data. There was a joke recently, I'm not sure where, getting away from a single pane of glass and instead ending up with a single glass of pain or something like that. It was pretty funny.
Awesome. All right. Well, I think that is all the questions we have for today. James, do you have any closing thoughts that you'd like to leave with the audience?
I think just again, the tools you use need to be oriented around solving the problems that you have, and they need to be based on accurate data. So spend the time to understand what problems you're trying to solve, what you or your developers need, and then figure out whether they're actually getting both the tools and the data they need to do that, and actually use the scorecard, because it will make a difference for your business.
All right, awesome. James, we actually had another question just pop in. The person is not really understanding the term cardinality as it's used in this context. Can you explain it? And they said that they're supervisors, so please use small words.
Sure. So there's let's say that you have a request count to talk about metrics. So you have something that says every time I get a request, I'm going to say I got one request, and send that into a metric system. Well, it probably is the case that you don't just care that you got a request. You probably care about something about what that request was. Maybe it was for a particular web page, or maybe it was for a particular piece of data. And so that's the first step, is you say, well, this was a request, and it was a request for this piece of data. And so that could be like request type, which would be a tag, and then the particular kind of data. And so you have keys and values. They're associated with measurements. How this gets interesting is when those keys are things that have huge amounts of variance. So if the number of both keys and values. If the number of values for a particular key is like 5 or 10 or 20 or whatever, it's usually not a big deal. But in order to collect that information in an accurate way, you have to store each one of those values associated with each one of the combinations that went together. So like if it's like one request for this piece of data, this type of request, which the type is data, then you have to do that, and you have another request that's a different type, and then you say, well, I need to know which machine this happened on, because I want to know if like a particular machine is slow. Well, then you say, okay, this piece of data was this request was handled for this particular piece of data on this instance. And then if you have 1,000 instances and 4 different types, then it's the combination of those 1,000 times 4. That's the number of actual things that you need to record in order to be able to answer the question, well, was this type of request slow on this particular instance? But then it just keeps going past then. Even if you don't have thousands of instances, the multiplication, that usually where things start getting really out there is when you have many customers, probably less customers than you have, or probably more customers than you have instances. But let's say you have 100,000 active customers. And so like the key is customer ID and the value is one of those 100,000 different customers. Collecting that point of data about this customer made this request for this kind of data on this instance ends up requiring just massive amounts of both compute and storage to be able to then ask questions about that data by customer. And so people just don't put these things, which are called high cardinality, but like a single key value like customer ID that has a whole bunch of different, a single key that can have a whole bunch of different values. They just won't do it because that multiplication will add up to millions and millions of different variants for the same measurement. And a lot of companies charge for that variance a lot. And so like it ends up unexpectedly blowing people's bills up as well for their observability. Did that answer the question?
Awesome. Yeah, I think so. I think that provides some clarity. Awesome. Well, I think that is all for today. Thank you so much, James, for sharing your expertise with us. And also a special thank you to the audience for attending today's webcast that was sponsored by Lightstep and presented by ADTmag.com. Have a great rest of your day, everyone.